So in this phase, we're going to create this shell prefab. It looks like this and has a number of different components. It's got a collider, a rigid body, it has a light component. And the idea with this is that obviously we'll fire it from the tank, but to demonstrate what it does, it has an overlap sphere. This is a kind of sphere of damage that it can give to any of the tanks that it lands near. So in this video, what I'm doing is slowly moving it closer to the tank. And what you should notice is that the health is getting reduced by more the closer that that bullet happens to be. Or at least I will do in a moment. There we go. Off we go. Moving it closer. So the closer it is, the more damage will be applied. Obviously, if you hit a tank dead on, then that will be the huge amount of damage. That's the shell that we're going to make. And then in the next phase after that, we'll handle the actual shooting. But first off, we're going to handle the damage, or the thing that's going to pass damage to the tank health script that we did before. Oops. What I would like everyone to do is to look in the models folder. In the models folder, you'll find a model called shell. If you select it, it should look like this in the inspector. Little note, if you want to inspect something, drag around it, you can just drag in that preview window at the bottom of the inspector. So what we'll do is we'll just drag that into the hierarchy. If you drag and drop that model from the project to the hierarchy, move your cursor over the scene view, press F to frame selected, and you'll notice it's at the origin roughly, so it's near to 0. So all I'm going to do is just to drag mine up slightly so that it's somewhere I can see it and work on it. Something like that should be fine. Remember, because we're creating a prefab that we're going to fire with the tank, this isn't something that's going to be in the scene when the game starts, just like the tank, so we don't need to worry about where it's positioned for now. So because we are making this something that's going to interact with other objects, it needs to have a collider. So we'll use primitive colliders because they're nice and performant. And given the shape of this, we'll use a capsule collider. So with that shell still selected, in the inspector, we'll hit the Add Component button. And I'm just going to type caps for capsule. And then click on it to confirm or hit return. With that capsule collider, because when you are firing things like a projectile, as we are, we don't want things to be bouncing off one another. We don't expect this tank shell to ever hit something and push it back. We're expecting it to hit something, create a callback in the script, and then create an explosion force. So we don't want any physical interactions. And when we don't want those, we use what's called triggers. If you hear someone refer to a trigger or a trigger zone, or a trigger area, they're usually referring to a collider that's been checked as a trigger. So if you check the is trigger checkbox on that, what that basically means is that it doesn't have a solid surface to it. It just means it can intersect, but it will send a callback to the script saying I've now entered another trigger or I've entered another collider. So often trigger colliders are used for things like doors in games, when you put a big cubic collider in front of a doorway, and then when the character enters that way, you automatically open the door. It's pretty classic use of that kind of collider. Once you've added that component, the next thing we want to do is to actually set it up. So we need to change the center. So the center value for that is 0, 0, 0.2. And the radius is 0.15. And the height is 0.55. Crucially, you'll notice that it's not looking in the right direction. So we set the direction to Z-axis. And then it should pretty much match our shell perfectly, or to an amount of precision that would never cause any issues. Should look like that. Cool. And then finally, because this is a physics object, we need it to be under control of the physics engine. So what are we going to add? Rigid body. There we go. Nice and loud. So add our rigid body component. And it's good to go. So these shells are going to fire, like a projectile. They're not going to just keep going straight forward. They're going to fall with gravity over time. So just a quick recap of those 2 points. Okay, so we found the model named shell in the models folder. We dragged it into the hierarchy. We've added a capsule collider component to the shell, and we've made sure it's a trigger so that that trigger won't bounce off of anything. It's just going to pass straight through stuff and then immediately be destroyed by the script that we're going to write. We've checked this trigger to make sure that that's the case. Then we set the direction to Z-axis, and we change the center. So the center is basically where that originates from, so you can kind of offset your colliders if you need to, art-wise. And the radius we've set to 0.15, so radius of the capsule, and the height to 0.55. And we added a rigid body to make sure that it's under control of the physics engine. Okay, so we've got the shell, and currently the shell can fall down and nothing's going to really happen. It's just going to go straight through the ground because it's not going to stop. It hasn't got a physical presence, like I said. So we don't want that. We want it to actually explode and do stuff. So we've created a shell explosion for you. So if you look in the prefabs folder, you will find a prefab called shell explosion. So what we're going to do with that is make it a child of the shell. So if you drag from the prefabs folder and drop it onto the shell, it should look like that. And when we simulate it, it looks like this. Cloud of dust that kind of falls over time. Okay, and then the only other thing that we need to do with that is to add an audio source. So similar to the tank exploding, it needs to have visual effect and an audio effect. So I'm going to click the Add Component button, and I'm going to choose Audio Source. And then, just like before, we need an audio clip, so I'm going to use the circle select next to audio clip and choose Shell Explosion to assign it. Now, we don't want this to play as soon as the shell gets instantiated, as soon as the explosion appears. So we're going to uncheck Play on Awake. Quick recap. So we've got our shell explosion prefab. We had to make it a child of the shell game object. So it's going to travel with it and then do its thing as soon as it hits something. We added an audio source to that so that it's able to play back sound, and we've used circle select to set the audio clip to shell explosion. We don't want it to play as soon as it enters the world, so we only want it to play as soon as it impacts. So we uncheck Play on Awake. Okay, and then the final thing we're going to do with the shell, so reselect the shell, the parent object, is to add a light. So as this travels across the game board, we want this to light up the environment. And it helps pick out the shell, because obviously you've got a gold shell, you've got orange sand, it's hard to see it, and the light really helps pick it out. So instead of creating a point light game object, we can just add that same light. So if you're new to Unity, what you'll notice if you go to Game Object Create is that you've got all of these ready-made prefabbed game objects with several components on them. So for example, if you choose, if there was a cube, then you've got a bunch of different components on it. But you could also create a light, which has just the light component on it. We don't need to do that. We're just going to put the component directly onto the shell. So I'm going to add component light. So now we have to actually handle how that behaves, how it's going to impact and what it's going to do when it hits a tank or when it hits the environment, and the kind of forces that it's going to apply to other tanks in the game. So what we're going to do is to look in the scripts folder and find the shell folder. In that, you will find a script called shell explosion. So we're going to drag and drop shell explosion onto the shell game object in the hierarchy. And then you should see that along with everything else, the rigid body, the capsule, collider, the light that we just added, you've now got shell explosion script. And we're going to double click on that to open it up for editing.
Okay, so in this one we don't have any private variables, but we do have a bunch of public ones. So the first one is a layer mask. Now, you might remember at the beginning of the day, we put all the tanks on the player's layer. So that means that when we cause an explosion from the shell, we can just check for everything that's on the player's layer and see which tanks we've hit rather than trying to affect everything. So that will be available in the inspector, and we can choose which layer we want to affect. The next is the explosion particles. So remember, we just dragged on that as a child game object. We're going to get a reference to that so we can play the particles when the shell explodes. Likewise, there's an audio source reference. So that's for getting a reference to that audio source so we can play a sound. Then we've got a bunch of floats. So the first one is the most damage that it can possibly do, the maximum damage. And we're setting that to 100. So if you get a perfect direct hit, then you'll kill the tank outright. But you can't get a perfect hit because it's never going to be exactly on the position of the tank because the collider is covering it. So you're going to get close but no cigar. The next one is the amount of force that the explosion is going to do right at its center. Likewise, as the explosion radius gets further out, the tank will be less affected by the explosion, you'll feel less force. We've got the max lifetime, so we don't want shells to exist forever. So if they happen to miss everything, we don't want them to stay in the scene forever, so we're going to give them a lifetime. And at the start of the scene, we'll say, it's not dead after 2 seconds, just kill it anyway.
So it's pretty unlikely you'd ever see that, it either hit the ground or some other object before that ever happened, but it's just a fail-safe that we'll write in. So
the last public variable is the explosion radius, and that is literally how far from the shell it's going to affect when it explodes. Okay, so let's look at these functions. And as I was just mentioning, the start function, we're saying destroy the game object after the max lifetime. So that's saying, when you instantiate this, if it's still alive after 2 seconds, destroy it. And now we're going to have to write some scripts. Okay, so the first thing we want to do when onTriggerEnter is called, so you remember we put isTrigger is true? That means that onTriggerEnter is going to be called when something bumps into this.
So this function will happen whenever it intersects with anything, and then we need to check what it's intersected with and what to do as a result. So we have this argument, which we just call other, which is of type collider. So it's going to say, okay, well, we've intersected at something else. It's a collider. What do we do about it?
In this case, we don't actually care what we're bumping into, just that it's a collider, so we should explode. But what do we do first? First of all, we need to gather up all the colliders that we need to affect. So we need an array of colliders, and you remember that's the square brackets after a collider. And we'll call that array colliders. And we're going to set that to the return of a function called overlapSphere. So that's physics.overlapSphere. And what that's going to do is, similar to a raycast, it's going to create an imaginary sphere. And everything that overlaps with that sphere or is inside the sphere is going to be collected. And we want that sphere to be at the shell's location, so transform.position for its position. It's going to have a radius that we've already got as an explosion radius. And we're going to use that tank mask so that it's only picking up the tanks.
Okay, so just a quick note about layers. Layers we use for various different things in Unity, but ostensibly they're just for grouping things together in some way that you want to use to either include or exclude them from something. In this case, we're using it as a way of only including or sort of masking out anything but tanks, which is why we've called this variable tank mask, because it's effectively a layer on which only the tanks exist. But don't think of it in any kind of visual terms. If anyone's familiar with Photoshop or anything like that, there's no kind of layering in that sense.
Okay, so now we've got all our colliders. We need to go through them all and decide what we're going to do. So for that, we need to loop through them all using a for loop. So this is the same format as we saw before. For int I equals 0. I is less than colliders.length. So this is colliders is the array that we're going through, so it's less than colliders.length. And then I++ means that we add to I for every loop. Then open and close brackets. Brackets? Yes, brackets. And then we can use whatever we do in that for loop to affect each of the colliders. So the first thing we want to do is check whether the thing that we've hit has a rigid body. So what we do is we create a rigid body variable, which we'll call target rigid body. And we'll set that equal to colliders I, so that's the collider at the position that we're currently iterating through in the array, dot get component rigid body. So we use the angle brackets for rigid body. So what that's going to do is get that collider that we've just gone through the array, try and find a rigid body on it. Next, we need to know if it's actually found a rigid body or if it's just found nothing. So what we're going to do is say if not target rigid body. So what that's going to do is say if there's nothing there, then what do I do? And if there's nothing there, we want to continue onto the next loop, onto the next collider.
So remember, it's going back to the start of the for loop and carrying on looking for any collider that's got a rigid body. It's not continuing through the list of commands.
So bear in mind that this is a bit of a safety catch kind of thing, because we're making everything that's on the player's layer anyway. So everything should have a collider, and everything that has a collider there will also have a rigid body. So we should always find something, but it's good to check just in case, because otherwise you're going to get errors. Okay, so now we know we've got a rigid body. What we can do is we're going to add a force to that rigid body. So target rigid body dot add explosion force, open parentheses. And the force we want to add is the explosion force that we got as a public variable. So it's m_explosion force, then comma, so we're on to the next parameter. And the position that that explosion force is emanating from is transform.position. So that's position of the shell. And then the last parameter that we're going to use is the radius, so how far away that explosion force can reach. Okay, so we've added the force now, so the tank is going to move, but we still need to actually cause some damage to it. So we're going to do something very similar. We're going to create a tank health variable, which we'll call target health.
So just to qualify that, notice that when we've made these other variables, they've been familiar components to things that you've added using the add component button. This time, we're making a variable of type tank health. So that just means an instance of the tank health script on a tank. Let's go back from the top. So we've gathered all the colliders we could find within the imaginary sphere, the overlap sphere, and we're looping through that list, that array, to the amount that there is colliders found. And then with each one, we're checking that there's a rigid body, and if there is, we're adding a force. But then we want to actually also take damage on those tanks. So we're addressing a particular instance of that tank health script so that we can talk to it and reduce health with it.
Okay, so we've got tank health, target health, and we're going to set that equal to the target rigid body get component tank health. So we've got a rigid body, we know that now because we were able to add a force to it. So on the same game object as that, get the component tank health. And again, we should know that there's definitely going to be a tank health here, but we're going to check just to make sure, because if somebody wants to extend the game and they make something that's on the player's layer that doesn't have tank health, then this will still work. So again, instead of if not target rigid body, we've got if not target health, and then continue. So if there's no target health, continue on to the next iteration.
So a quick note about this line here. So you'll notice that we've talked about the fact that we need to reference to this instance of the tank health script. So you might be wondering, well, what's that got to do with the rigid body? What's health got to do with physics? Nothing at all. The point is that we've found a particular game object. The fact that we're calling it target rigid body, it's not hugely important. We're just referring to the same game object that we've stored in that. Often when we talk about rigid bodies, we'll say, oh, this is a rigid body object. All things in the hierarchy are what we call game objects. But often what people will say is, oh, that's a rigid body object. It just means it's a game object with that particular component attached. So when we're talking about, oh, this is the target rigid body, we just mean it's the tank game object that we know has a rigid body attached to it. So we've done that check. And we can then say, we know it's the right game object, so we know it's got the tank health script on it, and we'll carry on from there.
Just to reiterate what Will was saying there, you don't need a game object to find a component on it. You can use a component reference to find another component. So that's what's actually happening there. It's got the rigid body component. We want to find another component on the same game object. That's what we're doing. Okay, so we know that we've got target health because we've not come out of the loop yet. So let's create the damage. So float damage is equal to this calculate damage function, which you can see at the bottom of the screen there, which we will write in a minute. But what we need to do is give it the position of the target, because we need to know how far away is that target from the shell when it explodes, so we know how much damage it needs to take. So you can actually get the position of something from the rigid body as well. If you remember back from the tank movement script, we were doing things relative to the rigid body's position. That's the position we're going to use here. So we've got the damage, now we need to apply the damage. So we've got the target health script, and we need to call the take damage function that we made earlier. And we're going to pass in the amount of damage. So that's all that we need to do for that for loop. That's all that we need to do for each of the targets that we've got. But we still need to make the shell explode and play the correct audio and stuff.
Yeah, another thing to just mention about this, we're creating a float called damage. We've got this calculate damage. Currently, if we played this, nothing would happen because we don't have anything going on in this calculate damage function just yet. But all we're doing is just setting it up so that when we do, we're going to pass that straight to the take damage function. If you remember when we looked at that tank health earlier, our take damage function there is public. That's how we're able to just reference it by saying dot take damage. Public being the accessibility level of that thing.
Okay, we've gone through all the colliders that we need to do. So now we need to sort out the particles and the audio. So when we detonate the shell, when it explodes, we want to remove it from the scene. We don't want it to hang around. However, if we remove it, then the particles are also going to be removed because they're children. And the audio source is also going to be removed because that's a child. So we want to make sure that those still play even after we've destroyed the shell. So what we're going to do that is to unparent them. So it'll come in as a complete game object, it'll explode, and they will decouple themselves. So the shell explosion will no longer be part of the shell. And we're going to do that by setting the transform's parent to null. So null just means nothing.
That means it will just be loose in the list of game objects in the hierarchy.
Okay, so we have detached it now. So next, we need to play the particle effect. So m_explosion particles dot play, open close parentheses, semicolon. And likewise, we want to play the audio source. So very similarly, explosion audio dot play. So then we just got a couple more things that we need to do in this function. We need to destroy the particles and we need to destroy the shell. So to destroy the particles, we're going to use the same trick as we did in the start function. We're going to give it a delay. So we're going to say destroy m_explosion particles dot game object. We don't want to destroy the particles because that will destroy the component. We want to destroy the game object that those particles are on. And we're going to do that after the duration of the particle system. So remember we said before it was just going to be 2 seconds, which was a number that we decided on. Well, particle systems, one of their properties is how long they last for. So we're just going to say destroy it after how long it lasts for.
Yeah, so not to be confused with the lifetime of each particle, but the duration is the entire system. So this, as you can see, autocomplete showing us here, optional amount of time before destroying the object. We can simply just refer to explosion particles dot duration, and that will simply wait for it to finish and then destroy it based on that. Which is great because you can then go and adjust the duration and this code will still take care of it for you. And as James was saying, the last thing we need to do once we've destroyed the explosion, or once we've triggered a destroy that will occur once it's finished playing the explosion, is actually just to remove the shell as well.
So to do that, all we do is destroy game object, and that'll destroy the game object that this is on.
As ever with scripting, everything's kind of just happening straight away. You know, it's not like we're waiting for one thing to happen, then something else happens. So, you know, theoretically, you might consider that you would get rid of the shell, then the explosion, but it really doesn't matter in this instance.
Okay, so the last thing that we need to do in this script is actually complete that calculate damage function. Okay, so in this calculate damage function, currently we've just got return 0f, and that's purely just so it doesn't spew errors while we're working on the rest of the stuff. So we're going to get rid of that to start off with. We don't need it. And the next thing we're going to do is create a vector from the target to the shell. So that is going to be vector 3 explosion to target. And that is equal to the target's position minus the shell's position, which is transform.position. So if you imagine a big circle on the ground, that's the explosion. At the center of it is the shell, and somewhere in that circle is the target. We're finding a vector between the two. The next thing we need to do is find out how long that vector is, the magnitude of that vector. So what we're going to do is say float explosion distance is equal to explosion to target dot magnitude. Okay, so now we've found that distance, which will be somewhere between 0 and the radius. We want to know what the relative distance is, because we want a number from 0 to 1, really, rather than a number between 0 and some radius that we found. So the relative distance, we know the maximum it's going to be is the radius, and the minimum is going to be 0. So what we need to do is calculate a number that starts off at 0 and ends up at 1. We do that by dividing by the explosion radius. So relative distance is open parentheses m underscore explosion radius minus explosion distance, then close the parentheses and divide all of that by the explosion radius. So when you think about that, if the explosion distance is very long, i.e. it's close to the explosion radius, then the explosion radius minus something that's very close to the explosion radius is going to be very, very small. Divided by the explosion radius is going to be very, very small, so it's going to be near 0. However, if the explosion distance is very small, then the explosion radius minus something very small, let's say 0, divided by the explosion radius is just going to be 1. So we're going to end up with a number which starts off at 1 near the center and trails down to 0 at the edge. And that's how we're going to calculate how much damage is done. So we'll create a float called damage, and that's equal to the relative distance multiplied by the max damage, so m underscore max damage. So when the relative distance is 1, i.e. it's very close to the center, then you're going to deal the maximum damage. When it's close to the edge, it's close to 0, you're going to deal very little damage.
Okay, so as illustrated in this slide, we have our overlap sphere. We have our tank right at the very edge of it, very minimal or maybe 0 damage, and something right in the middle of that impact, such damage, meow.
We're not finished yet with this function. So what we need to do next is make sure that the damage is not negative. So we're going to do that by saying damage is equal to mathf.max of 0, f, and damage. So all that's doing is saying if it's negative, to set it to 0, otherwise keep it as it is. And then finally we can return that damage. Why is it that we're making sure it's not negative? Well, there is literally an edge case in this scenario. So in the case that the tank is right on the very edge, its position is actually outside of the overlap sphere, but its collider is within it. So it's going to get picked up by that collider's array, and then it's going to be calculated in with everything else. But we've only caught the edge of it, so we're actually going to calculate a relative distance that's negative. Because you're starting off at 1 in the center, going down to 0 at the outside, and then it'll be negative beyond that. So we don't want negative damage, we don't want to shoot things and make them more healthy. It's just not the way. So that's why we're doing that.
Cool.
Should we put the script back on a bit, just for people?
Mm-hmm. Okay, so if you've saved your script, switch back to the editor. Hopefully there won't be any errors. And then we need to, of course, populate our script with all those public variables. So interestingly, something you won't have seen before is the first public variable. It's this tank mask. So remember, it's of type layer mask, and we called it tank mask. And what that basically gives you is a repeat of all of Unity's layer system. So you'll notice it's the same list that you get in the layer drop-down at the top. This tank mask is where we're going to select players. That's the only thing we want it to actually affect. So select the players layer from the tank mask variable or drop-down. Then explosion particles is the child object that's underneath the shell. So you can drag a shell explosion onto explosion particles. You'll notice in the parentheses there it says particle system. And for explosion audio, it's the same object because that also has an audio source. But this time when you drag it, you'll notice it picks that component. So Unity's smart that way. It knows which component you're referring to. If you drag an object that's got that component, it will say, great, okay, that must be what you mean, and assign that particular component from the game object that you drag in. Then the other stuff that we've set up there, it's set up based on the game that we wanted to make. If we get to the end of the day and you want to have a huge amount of damage, you want to have one-shot kills, then you just up the maximum damage or add the explosion force and the tanks just get flung all the way off the screen. You can do that stuff. Obviously up the explosion radius as well. You can play around with that. For now, let's stick with these values, see how we like that. And then the last thing we're going to do is to save the shell as a prefab. As I said before, we don't want it to be in the game when it begins. So I'm going to select my prefabs folder. I'm going to drag my shell and drop it into the empty space in that folder. So really, we should check if this works. So I'm just going to briefly save my scene and demonstrate what you should be seeing. So if I press play right now, my shell should fall down and, because it's pretty near the tank, take off quite a lot of damage. Take off a lot of health, apply a lot of damage. We've applied the shell explosion in order to populate the particle effect and the audio source onto those two different variables. And then we've made it into a prefab. So now, as mentioned before, we don't need that shell in the game. Delete it out of your scene. So delete on PC, Command backspace for Mac, and then save your scene. One more time, select the shell, delete it, and then save your scene. Okay, so that's the end of phase 5. Then the next phase, we're going to deal with actually shooting these projectiles. So a little bit of physics and a bit more UI